Hello everyone, welcome to this video tutorial on numerical integration in MATLAB with Simpson's one-third rule. So this is the formula we are going to use to develop this or to program this in MATLAB. The learning outcome of this video, after this video lecture, you will be able to create user-defined functions to solve numerical integrations using Simpson's one-third rule. And these are the problems we are going to solve. Initially we are going to numerically integrate 2x plus 3, and after that we will be taking an integration of sine x. So let's move to the MATLAB. We'll start with a live script, and I'll first of all make some instructions. I'll write some instructions. Simpson's one-third rule for numerical integration. Okay, then the inputs of this video. Inputs of this function, I'll say inputs. The first input will be f of x. F of x is the function on which integration has to be done, or we have to integrate, function which we have to integrate. Okay, the second term will be the a and b. These two terms are the limits of the integration. Then n are the total number of the sub intervals. Yes, those are the inputs required for this function. Then output will be output will be approximate integration or integration, I'll say integration I. Okay, so let's start with writing the code. So we have to write the function. It starts with the function keyword, then the output is I, that's integration, is equal to, we'll name this function using Simpson's one-third rule. Simpson's one-third rule, and the inputs are f comma a comma b comma n. Now we'll I'll add this formula here for Simpson's one-third rule. So integration, so you can insert your equations from here. Integration, so you want integration, definite integration a to b, and here f of x dx is equal to Now we have to add some fraction. This is h by 3 into and then we have to add some index terms. This is y0, or else copy this y0 plus control v. This is yn, then plus 2 into control v y2. This is going to be 2 plus y4 plus dash dash dash. So this is nothing but all the even terms, then plus 4 into y1 plus y3 plus y5. So these are nothing but all the odd terms. And here the next line will add h is equal to fraction b minus a by n. So this is what we have to program. So first of all, we'll start with calculate the sub interval, calculate the h, which is nothing but the sub interval. So h will be b minus a by n. This we have to remove. Yeah. So press this output. Yeah. Then initiate this remaining term, this bracket term. So this is nothing but the sum of y0 plus yn plus 2 into all the even terms, then 4 into all the odd terms. Let me check once again. We have written this formula correctly. So 2 into odd even terms in plus 4 into even terms. Sorry, 2 into even terms plus 4 into odd terms. Yeah, correct. So 2 into even terms plus 4 into odd terms. Correct. So we have to initiate a variable. So initiate the sum variable to store the sum of y0 to y. Okay, so we have to initiate sum where initial two terms are y0 and yn. So y0, what is y0? Y0 is equal to f of x0, which is nothing but f of a, and this goes on y1 is nothing but x1, and there is no this thing. So this will become xa plus 1 star h. Okay, then y2 and this goes on up to yn. So yn is nothing but we have to substitute the value of b. Xn is nothing but b. So this is going to happen here, and we'll first start this sum with y0 plus yn, because these terms are not going to be changed. Now what we have to do, we have to use subs. This is the function, inbuilt function to substitute the value of xn in f of x in f of x in place of x. So this x is nothing but a symbolic variable, and we are going to substitute or replace this value x with xn. So like this, xi x0 comma x1 comma x2, like this, comma dot 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 comma xn. So this is the inbuilt function. Now how to do that thing? Let's start with substituting in f. What we have to change? We have to change x with a. So this becomes our f of x0 or y0. Similarly, for yn, we will change this thing with b. Okay, so this is this becomes our a and b substitution in f of x, or this is nothing but y0 plus yn. Okay, I'll replace this thing or copy this thing and just here. So hope you got this. This is how we initiate the sum variable. Now we'll go to the function. We are done with these two terms. Now what we'll do, we'll we'll add these remaining terms to the variable sum. Now for that thing, we have to differentiate, or we have to segregate between odd and even terms. So for that thing, what we will do, we'll start with the for loop. For and iterable I is equal to 1 is to n minus 1. So here why I am writing n minus 1, because this is the term n, yn or xn we have replaced. This is nothing but the b, and I am not starting with 0 because this is the y0. Okay, then the next term will be xi. Xi is nothing but the increment in a. This is going to be xi, what we have to replace. So this will be x1, x2, x3, and we're not going to change this xi as name of the variable, but the values here stored here will be changing at each iteration. Okay, now sum will be equal to sum plus substitute in f, in place of x we have to substitute xi. Okay, but there is one change now here. Now what we have to do, we have to multiply 2 with all the even terms. We have to multiply 2 with all the even terms. For that thing, we have to write if loop, and if mod of I, that is iterable, comma 2 is equal to 0. If this is equal to 0, this means that I is nothing but the even term, and in that case we have to multiply this 2. Okay, this thing. Else, now what we'll do, we'll just give the smart indent to this thing. Else this sum will be equal to sum plus 4 into into substitute f in place of x, substitute xi. Okay, so here if the I is 2, 4, 6, 8, then 2 will be multiplied with those terms, and else 4 will be multiplied with the odd terms. Okay, this ends your if loop and this ends your for loop. Okay, now at the end, what we have to calculate? We have to calculate the integration. Okay, now I is nothing but h by 3. So if I multiply h with sum and then later divide by 3, it becomes I. Okay, and this is your output. So we have completed our function. Here ends your function. Okay, now the next part is to saving this function. Okay, to save this function, go to live editor and click on the save, and you have to save this with the Simpsons tool.mls. Okay, so the function is saved now. Okay, now just to call that function, you can open new live script. Okay, and here what you have to call, this function. To call this function, what I will do, I directly copy this and paste it here. Okay, so Simpsons tool, I am going to call the function f. So I did one mistake here. I forgot to initiate sims, because this is going to be a function with a symbolic variable x. So you have to write sims here, and this is nothing but the symbolic variable. So what is this? This is the initiate the symbolic variable. Okay, so this is the symbolic variable x, because this f is going to be a function of x, and that x we have to replace with a, b, or x0, x1, x2 up to xn. So this is very important, otherwise it will give some error. Okay, also while calling that function, you have to declare this symbolic variable here also. Okay, after that write f is equal to 2 star x plus 3. So this is going to be a symbolic variable. Now your a is nothing but 0, b is nothing but 10, and n is going to be 10. Okay, so this is initial limit of integration and final limit of integration. Limit of integration. Okay, and number of subintervals. Subintervals, yes. So this I is going to be this thing. Okay, Simpsons 1/3 true. Now we'll run this section and check for outputs. Now this sub, yes, we have some error in Simpsons 1/3 rule. This, and here forget to write complete function name subs, and we'll save this and we'll once again run this thing. Yeah, so we got the value 130. Now if we cross check this with our problem which we have solved using conventional method, we got this 130. Now we'll solve this for sin x with limits of integration 0 to pi. Now I'll write one more, and here this time I will change to sin x. This is going to be a pi, and yes, we'll keep 10 iteration 10 subintervals for this time. We'll check the results. Now you can see here, instead of getting the exact result, we are not getting the exact result and we are getting this thing. And I don't know how to read this thing, but you can change the code, source code here. If you write this VPA here, you get in a Simpsons one-third rule function in front of I'm changing the code. I'm writing this VPA here. What it will do, it will approximately solve that equation and give us a value. Okay, so if we'll save this once again and if we run this once again, we are going to get the results. So the final value of integration we got is 2.001095. So this is how the Simpsons one-third rule works. Okay, this here we ends our tutorial, and thanks for watching this video. Please like, share and subscribe to the channel.